Good morning, students. In the last class, we discussed about managing the system. In that, we discussed about types of systems based on the evaluation of the maintenance that are categorized into S-type, P-type, and E-type systems. So S systems means that there is no change occurrence, and P-type means there is a little amount of changes occurring. In each iteration we are going to do some modifications, but in the case of E-type system, the whole world is going to be changed. Example, we have seen banking instructions and trading instructions or laws by the government. The total business nature is going to be changed. So with that we are making the constant changes in the we are seeing the constant changes in the E-type of the systems. So in today's class we are going to discuss about examples of change during the software development. So here in which phases we are having the whenever we are doing some activity from which initial change results. So during the maintenance we need to do some modifications in the any one of the phase of the software development life cycle. So we know that a software development cycle is having the 7 phases. So in whenever we need to do maintenance, we have to do some modifications in some phase. So that means if the requirements are wrong, if there is a fault in the requirements, so requirement need to be changed. According to that requirement we need to be modify the design. According to the design we need to be change the coding. According to the change in the code we need to change the test cases to test that code. So like this we are having the series of impacts on one phase changing is on the other phase. So here in this slide we are seeing that information on which phases we are having the maintenance effect, and due to that one what are the things are going to be, what are the artifacts required consequent changes. Okay, so whenever you are doing the maintenance, so that some particular phase is going to be modified. So whenever you are doing something modification in that particular phase, what are the artifacts are going to have an impact. So that are listed out here. If you see requirement analysis, if you do the changing the requirements, the requirement specification document will be changed. If you are changing the system design, architecture design specification document, technical design specification document content will be changed. Program design, so when you change the programming design, program design specification will be changed. Program implementation, program code will be changed, and program documentation will also be changed. Whenever you are doing the unit testing and system testing, test plans and test scripts will be changed. So in the case of a system delivery, so as you change the requirements, you need to change everything in the system delivery: user documentation, operator documentation, system guide, programmer's guide, training classes. So as you added the new functionalities, so how to use those new functionalities, we need to give an awareness to the users. So for that we need to conduct a training classes for the newly added functions. So whenever you are making some changes in the particular phases, see these respective artifacts are going to be having an impact. Next one is system lifespan. So we will need maintenance phase. The question is whether we need compulsorily the maintenance phase in the software engineering. Answer is yes. So why? Because even though you built a software product with all the implementation of all the inclusion of the design principles, meaning that inheritance, abstraction, encapsulation, high cohesion, low coupling, low dependency. Okay, you implemented every design principles with a good qualitative product. Even though you need the maintenance phase. So why? Because in our daily day-to-day life, the software changes are changing from today to tomorrow. Okay, so in this aspect, if you see with respect to the E-type and P-type systems, the changes are occurring. So in software industry there is no system without any changes. So compulsorily we need the maintenance to incorporate the changes as per the user requirements, or else as per the nature of the business change. So we need to make the modifications, we require the maintenance. So anyway you have made a good qualitative software product, compulsorily we require the maintenance phase. Right. So next one is development time versus maintenance time. So here we require whether we are required more efforts for development or maintenance. So what is your answer? So whether we require the more efforts on development, more efforts on maintenance. So as we people know little amount of the software engineering phases, so we thought that more efforts are required for the development and less amount of effort is required for the maintenance. So because to develop the product we are taking the lot of amount of time, and we require requirements, design, everything we require. So you think in that aspect, you may give the answer is most of the time is most of the efforts are required towards the development and less efforts are required towards the maintenance phase, but it is wrong. Why? Because maintenance means whatever the faults are occurred in the existing system, or whatever the enhancements you want to do in the existing system. So we need to be touch every phase in the maintenance phase also. Okay, whenever you are doing the maintenance, you need to change some requirement specifications. So meaning that you are changing the requirement specifications, you are modifying the requirement specifications. So when you modify the requirement specifications, according to that fulfilling of the requirement specification, you need to do the modifications in the designing. In the designing, when you made some modifications, you need to do modifications in the program design. So when you do some changes in the program design, according to that you need to write the code. Implementation should be mapping to the your programming design. So as per the programming code, you need to write the test cases. So all these phases you are touching when you are making the maintenance phase. So maintenance phase is indirectly is having the all the phases. Okay, so now from this explanation, I think you understood development time is a part of maintenance. Okay, so maintenance is also involved with the development time. Okay, meaning that during the in the development time you are developed. Okay, all the phases through you develop a product. Okay, but when you are doing the maintenance, at the end we are having the maintenance, but whenever you want to do some modifications or some extensions, again you need to be touched from the first phase to last phase. Okay, to make the next iterative product, you need to touch every phase. Okay, so here the more effort, because you need to take the feedback, you need to identify what kind of extensions our users are expecting, what kind of changes are done in the business environment. So these need to be identified. That is a maintenance, and for this maintenance is required some effort, and in addition all the phases we are touching, this is also required some additional effort. Okay, so now we can understand that development time is taking the less effort and maintenance time is taking the more efforts. Okay, so some of the authors are made some observations or surveys based on their experiences. They notified what kind of effort, what amount of efforts are required for development and maintenance time. So if you see Parikh and Dwelag Zhao, he said that development time is required 2 years of time and the maintenance time is 5 to 6 years. So now you can observe 5 to 6 years, it is a more than development time. So next author is specified 39%. It is specified in the percentages. So 39% of effort in development and 61% of effort in the maintenance. So you can observe, you can notify this one, more than 50% of the effort required for maintenance. Okay, so next from all these they have come to some conclusion that 80-20 rule. So what is this 80-20 rule? 80-20 rule means 80% of the effort is needed for maintenance and only 20% is effort is required for the development. So from all of these we come to the conclusion that development is taking the less effort and for maintenance we require the more effort. Okay, so that is 80% of the effort is required for maintenance and 20% of the efforts are required for development time. Right, so how much change can we expect? So meaning that whether we need to replace the whole system, whether we need to be modify the some part of the system, how much time we need to do this modification of some part of the system in the existing system, at what time we need to think that we need to take a decision, the new system has to be replaced the old system. So that is the aspect here, system evolution versus system decline, better to discard and build a new. Okay, so when we will take this kind of decision, so better to have a discarding of the old one and build a new, completely a new software from the scratch. You need to be build it. Okay, destroy the old one and build a new one. So when we will take this kind of decision, so here we are having some of the questions. So when we are having these questions, some of the questions answers more than if you get at least for 3 questions positive answer, then you can have an option that you can replace the old one with the new one. You can replace the old one with the new one. So what are these questions? Is the cost of maintenance is too high? If you want to, if you're maintaining the old system, it will if it will take more cost for the maintenance, then better to have a replace of new system. Is the system reliability is unacceptable? So reliability means your system is not working properly as much as. So then whenever the reliability is less, then without faults your system is not working, then better to replace with the new one. Can the system no longer adapt to further change? So whenever you want to do some modifications in the existing system in the further iterations, so whenever it is not adaptable to incorporate those changes, not feasible to incorporate the new changes in the existing system, then go with a new system. Completely a new system need to be replaced in the old system. Is system performance still beyond prescribed constraints? Are system functions of limited usefulness? So I think you can understand by reading these sentences. That is why I am not explaining. Can other systems do the same job better, faster, or cheaper? Is the cost of maintaining the hardware great enough to justify replacing it with cheaper, newer hardware? The entire set of costs associated with the system development and maintenance from the system so here we are having these number of questions 1 2 3 4 5 6 7. So if you get at least for 3 questions yes answer, then you have to go with the new system. So better to have a new system instead of using the existing system. Okay, so by posing these questions, by getting the answers for these questions, you can take a decision whether you have to go with the existing system or whether you have to replace the old with a completely a new system. You can take a decision based on these questions answers. So you can see here the entire set of costs associated with the system development and maintenance from system creation to retirement is called the life cycle cost. Okay, so what is meant by life cycle cost? Life cycle cost means when you have built a system, from the building the system, when you started the gathering of the requirements and to deliver the system, and you delivered that product and you collected the feedback from the users and you are doing the maintenance. That means you are releasing the next iterations, you are doing the modifications in the existing system itself. Okay, so from the birth of that software product to destroy that software product. Okay, so whenever you are replacing this old one with the completely a new system. Okay, so up to that time, what could be the period of from the birth of that software product to the destroy of that software product? Destroying means, so you are replacing that software with the completely new software. Okay, so what could be the time period between this time period? We are calling it as a life cycle cost. What could be the cost it is taking from development and maintenance to retirement? Okay, to the retirement of that software product. So this time period we are calling it as a life cycle cost. Last point, we make the decision to maintain, rebuild, replace based on a comparison of life cycle cost for old, revised and new system. So finally you can take a complete positive decision, authenticated decision based on this comparisons of the life cycle cost. What could be the life cycle cost of old system? What could be the life cycle cost of the revised system? What could be the life cycle cost of the new systems? So based on these life cycle cost comparisons, you may go with the old system, revised or new system. Okay, we'll take a decision. Now, loss of software evaluation. The layman he has observed the behavior of a system as they evolve. The layman has observed when the system has evolved, what are the changes are taking place. He has summarized his findings in 5 views of a program evaluation. So this is a very important one, loss of software evaluation. So during the evaluation of the system, what are the changes are taking place in the software system. So on his observation, he summarizes some of the 5 laws. So first law, continuing change. So whenever the system is not adaptable for or not making continuous changes, so that software will not be useful. there is no more use utility or for the that software product. So as per the needs of the user and as per the needs of the business environment change, so we need to update the software, we need to do the maintenance for the software. So if you are not incorporating the changes in the software, the system will no more use. Okay, so meaning that we are having, for example, we are having the as an example, we are having the library online library system. So we incorporated nowadays we are having the reading of the barcode with using the barcode machine. So now we need to be introduced that one. So we need to enhance, so to reduce the work effort, to simplify the task, so we need to enhance some of the system functionalities. So for that, what we require, we need to add the barcode machine, and it has to be read, and it has to be identify what the student and what the student details, it has to be updated in the system, it has to be identified in the student database. So as that way, whenever the user requirements are changing and the business environment is changing, the software system what we have already built, it should be able to incorporate those changes. So if it is not incorporate or adaptable for changes, then there is no more use for that software. So it should be continue changing. So increasing complexity. So as the user requirements are changing and the business environment is changing, so we need to do some modifications in the system. Whenever you are doing the modifications, the design will be changed. So whenever you are making the design changes, so more complexity will be increased. Complexity means, so more dependency is there between the modules. Okay, so whenever the design is a very complex, automatically what will be happen, it is reduces the performance, and whenever you want to do some modifications, it will be take more time to do that modifications. So this is the increasing of the complexity. So to reduce this complexity, we need to be simplify the design, and we need to maintain properly these complex systems, or we need to reduce the complexity. Next one is fundamental law of program evaluation. So program obeys statistically determined trends and invariants. Program evaluation is a self-regulating process. System attributes such as size, time between the releases, and the number of reported errors is approximately invariant for each system release. So whenever you are releasing the systems in a sequence of series of the system releases, there should not be any changes, meaning that with respect to the time period between the releasing of that each version, and the number of errors are identified, and our standards, organization standards and programming guidelines should be followed. Those regulations need to be incorporated. So this is the fundamental law of the program evaluations. Next one is the conservation of organizational stability. Global activity rate is invariant. So meaning that here, conservation of organizational stability. So whenever you are having a maintenance phase of your software product, if you use all the resources, what the resources are required for that software maintenance, if you use all the resources and more than what we require in an optimum level, also the output is not having significant change. So the outcome of that utilization of those resources, there is no significant change in the output. Okay, so because we mentioned that in the fundamental law of the program evaluation, so there should be some invariant cases, there should be a fixed time periods from one release to another release. Okay, so because of that, whenever, even though you are using the more number of resources to work on the maintenance, there should not be a significant impact or effect on the output. Next one, conservation of familiarity. So whatever the releases you are releasing continuously in the each iteration, there should be a little amount of change is there in the system in the existing system functionality. So automatically, whenever you are having the version 1, whenever you are releasing the version 2, there is some little amount of changes are there in the version 2. Just as we see, whenever we are having the update versions in the MI phone, themes change or a screen lock screen or home screen is changing, you can identify what are the changes are there in the particular system updations. So this is the way, whenever you are having the in each version of the system, we can identify some little amount of the changes in the next versions. Totally, these are the 5 observations: continuing change, increasing complexity, fundamental law of program evolution, conservation of organizational stability, conservation of familiarity. So once again I will repeat: continued change. So your system need to be incorporate or adaptable for ready for the changes. So if it is not ready to adapt the changes, your system is no more use. Increasing complexity. Whenever you are using system, whenever you're incorporating the user requirements and changes in the existing system, automatically the structure design will be changed, so more complexity will be increased. So we need to reduce this complexity to make or you need to maintain this very efficiently the complex system. So complexity is increasing. It is one of the observation. Next, fundamental law of program evolution. So there should be a some invariants in the programming standards. Whenever you're releasing the system, there should be a time gap between the one version to another version releases, and there should be a perfect number of errors allowed, and what could be the size of the program that could be having some regulations in that there should not be any variant in these attributes. So that is the fundamental law of program evolution. And another observation is conservation of organizational stability. Even though you are using the more number of resources on the maintenance, there is no significant impact on the output. Next, conservation of familiarity. Release content changes is statistically invariant. So whenever you are releasing the sequence of versions, there could be a we can observe that there could be a definitely little amount of change in the new release of the system. These are the 5 laws of the Lehman.